First question is fairly simple. Round each of the following numbers as stated. Make sure you read the question very carefully. This question is to one decimal place. This is to two significant figures. This is to two decimal places. And this last one is to one significant figure. So, 3.741 to one decimal place is your first decimal place. Decide if this is going to stay the same or go up. It's going to stay the same because this 4 is less than 5. So it's just 3.7. This one, two significant figure. Here is your second significant figure. Now decide if this is going to stay the same or if it's going to go up. Well, this 4 is less than 5, so it's going to stay the same. Now, this, if you leave it as this, you're completely wrong. Now, we are to round these. This 30 is nowhere near 30,000. So it has to be 30,000. Second decimal places. So this is your second decimal place. Now decide if this is going to go up or stay the same. It is going to go up because the next decimal place is more than 5. So it's going to be 0.0. Now we said this is going to go up, and that's going to go up by 1. And notice your final answer is two decimal places as well. Last one. One significant figure. Here's your first significant figure. This 2. Now this 2 is going to go up because it's 5 or more than 5, and it's going to be 3. Well, that's in the 100,000, so it's going to be 300,000. Done. Next question, question 2. Question 2 is to use your calculator. Now, if you're struggling with this, I am going to put up a video on Show My Homework. There's going to be a link on what to use, how to use your calculator. The answers to these, I am just going to state them. If you are still struggling with these kind of questions, the video is going to be put up. With these kind of questions, you must make sure you write down every single digit you see on your calculator, and then you round up. A lot of you, I know you're looking at your calculator, you're thinking you're going to be saving more time by just writing it down to 3 significant figure, because that's what the question's telling us to do. But it's best to write down every single digit and then do it to 3 significant figures. If you're still struggling, I will put up more questions for you to do to practice using your calculator. Okay, question 3. Interestingly, you need to make sure you read a question very carefully. Question 3 is telling us to estimate the volume and surface area of the cuboid shown. Give your answer to one significant figure. Right, so let's start by working out the volume. Now, because we are working out the volume and it is to estimate, we are going to round the measured lengths to one significant figure. That's what we need to do when we are estimating. So this length is in fact just 3 centimeters. This one is 5 centimeters to one significant figure, and this one is 6 centimeters to one significant figure. The volume of any cuboid or any cube is its length times width times height. Its length we're going to call 3 times width, here it is 5, and times the height, which is 6. And when you do this, 5 times 6 is 30, times up by 3 is 90. Is it 30? 5 times 6? 30 times by 3 is 90. And we're working with volume, and it's measured to centimeters, so it's centimeters cubed. Now, for the surface area, to estimate the surface area, because there are 6 surfaces through this 3D shape, and each surface is a rectangle, we will have 6 calculations. 6 surfaces, 6 calculations. I am going to work out this bottom here, the one that's on the ground. Now the bottom has a length of 3 by 5, so it's 3 times 5. Now the opposite end of the cuboid, so the top is also 3 by 5. So that is also 3 times 5. Yep, so that's 3 centimeters because the length that's parallel to it is also 3. That is 5 centimeters because the length parallel to it that's measured is also 5. Now let's measure the sides. I'm going to use blue for the sides. So this side here is also a rectangle. Now this side is a 5 by 6. So we're going to do 5 times 6. Oh, let me just quickly write down the answers to the ones above. So 3 times 5 is 15. Another 15. Now let's go back to the side. So 5 times 6 is 30. And the opposite end of the cuboid is also going to be a 5 by 6, which is also 30. Now, we have missed the face, so let's work out what the face is going to be. The face of this cuboid is a 3 by 6. Yeah? The length opposite parallel to it is also 6, so this length is also 6 centimeters. So 3 times 6 is 18. Another 3 times 6 for the opposite end of the cuboid, which is at the back. Another 3 by 6 will also give you an 18. Now, for the total surface area, we need to add all these 6 calculations up. So, summing them up would give us a total area, surface area. Here we have 30 together. Another 30 is 60. Another 30 is 90. 90 plus 36 is 126. Because its surface area and the shapes we've worked out are all two-dimensional, it's going to be square centimeters. The total surface area is 126 square centimeters. Right. Moving on to question 4. Question 4 is fairly interesting. I like this question. Now, a circle has a radius 33 centimeters, correct to the nearest centimeter. So, the thing that's been measured is the radius, hence the radius has rounding errors. Let's just see. I'm just going to do a sketch. So here's my circle, and I'm going to call it R, where R is 33 centimeters to the nearest centimeter. Now, nearest centimeter is written like this, 1 centimeter, and to get the rounding error, we need to divide this by 2. So that would give us 0.5 centimeters. So the max the radius could have been is 33 plus the 0.5 centimeters, which is 33.5 centimeters. And the minimum it could have been is when we take that away. 33 minus 0.5 centimeters, which is 32.5 centimeters. Now let's read the question, the rest of the question. So we got the information. Now it says calculate the maximum and the minimum possible areas of the circle. Correct the 3 sigma figures. Now, big radius. If we had a big radius, we'll call it big R. Implies we would have a big area. So this is just obvious. So if we had a bigger circle, radius R, we would have a bigger area. And if we had a small radius, small r, this would imply we would have a small area. So when the radius is at its max is when the area would be at its max as well. So we are trying to work out a maximum possible area and a minimum possible area. And when the radius is at its minimum, The area would also be at its minimum. How do we work out area of a circle? Well, obviously we would know this. Area of a circle, or any circle, is pi r squared. So, to work out the max area, I'm going to call it max A for area, is when the radius is 33.5 centimeters. And putting this into our calculator, so I'm going to start calling it MAX. So area max is, what I'm going to call it, is pi times 33.5 squared, and it's as easy as typing it into your calculator. 33.5 times 33.5, and then timesing that with pi has given me 3,525.65235 ... and it goes on forever, centimeters squared. That is its max area. Now, to three significant figures, the max area is 3530. Now, for the minimum area, or min area, is when the radius is at its minimum. Here's the radius at its minimum, so 32.5 centimeters. And I'm going to call it a min, is pi times 32.5 squared. So 32.5 times that by pi, and when you do that and when you put it into your calculator, you would get this: 3,318.30724 centimeters squared, or square centimeters, forgive me. And this, to three significant figures, because they want their answer to three significant figures, is 3,320 square centimeters. And, whoops, forgot the centimeters at the top. And that is it. We're finished. We've worked out the maximum the area could have been, and the minimum the area of the circle could have been. We are done. Just a quick heads up, remember to write down everything you see in your calculator. Put ... if you do not want to write down everything, but show the examiner that you understand what you're doing, and then rounding your answer. Next question. Question 5. If A and B are given as A is 3.21 and B is 9.47, correct two decimal places, calculate the maximum and minimum value of each expression, giving your answer correct to 4 significant figures. Okay, so the things that have been measured and have rounding errors is A and B. A has a rounding error of 2 decimal places, and B has a rounding error of 2 decimal places. Okay, so the first thing I'm going to do before I even begin to answer this question, because I know that A has a rounding error and B has a rounding error, and now it's asking us to work out max and minimum, is I'm going to work out the maximum A could have been and the minimum A could have been. Now, because A has been measured to 2 decimal places, 0.01 is to 2 decimal places, divide that by 2 is 0.005. So, the maximum A could have been is 3.21 plus that 0.005, which is 3.215. So strictly less than 3.215, and the minimum A could have been is when we take that away, so 3.215, so minus 0.005, and that is equal to 3.205. And I'm just going to write this down as a inequality. So 3.215 was its max. It's strictly less than 3.215, so it cannot be 3.215. And it is greater or equal to 3.205. Now, for B, because B has also been rounded to do decimal places, and it's exactly the same format. I'm not going to do my working outs here because it's to 2 decimal places. It's still going to have something like this. Now, instead of 3.21, it's going to be 9.47. Instead of 3.21 here, it's going to be 9.47. So B has a maximum of 9.475 and a minimum of 9.465. And here's the only thing we need for any of the working out. I'm just going to shrink this and move this just in case we need to use it again. And let's go answering questions. Now, with A, one thing I liked was this. I'm not going to say who did this, but the notes they made was fairly nice and I enjoyed it. If you have a division, when you have division, this is what they said. The students said. They can say who they want, who did it if they want to. Anyway, when you have a fraction a over b, if you want the max, you need the max of a divided by the min of b. And if you want the minimum value of a over b, is the minimum of a, so the smallest a could have been, over the maximum of b. It is still the same fraction. Remember, we are trying to work out the maximum of a over b and the minimum of a over b. And the only way we can do that is when you have the maximum of a divided by the minimum of b for the max. And for the minimum, the only way you can do that is when you have the minimum of a over the maximum of b. So, really like the notes they made. I'm going to shrink this down to help us out. And let's move on. So we have the expression a over b, and a over b, if we want to work out the max, we need the max a could have been. The max a could have been is 3.215 divided by the minimum our b could have been. And the minimum our b could have been is 9.465. Putting this into your calculator, so 3.215 divided by 9.465 gives this 0.33967247775, and our answer to 4 significant figures, because that's what they want, the answer to 4 significant figures, is 0.3398. So the maximum this calculation could have been, or this expression could have been, is 0.3398. Now the minimum, again, it's going to be, now for the minimum, is the minimum of a divided by the maximum of b for this expression. So the minimum of a, the minimum of a is 3.205 divided by the maximum of b. Maximum of b is 9.475. And putting this in our calculators, so 3.205 divided by 9.475 gives 0.338258. 5857, something looked weird, 5752, and this to 2. to four significant figures is 0.3383. Now a fancy way to finish off this question is the expression A over B has a maximum of 0.3398 and a minimum of 0.3383. All answers to four significance figures. Okay, now we've done A. Let's move on to something else. Now for the calculation A squared, fairly easy to work out in maths. The only way this could work is if you have a big number multiplied by a big number. So 3.215 times 3.215, and this gives a value of 10.33633622 and our answer to four significant figures is 10.34. So that's the max, and the minimum is when you have a small number squared. So 3.205 times the 3.205, and this would be 10.272025, and this to four significant figures is 10.27. Again, want to finish off in a fancy way. So the biggest A could have been, or sorry, A squared could have been, is 10.34, and the smallest it could have been, sorry, strictly less than 10.34, and the smallest it could have been is 10.27, and that is our final answer. Okay, next one, A plus 2B. Moving on, this time we have a expression A plus 2B. So A plus 2B, we're trying to work out the maximum of this expression. Now the maximum again is when you have a big number, 3.215, plus another big number. Now this big number is going to be 2 times B, and the biggest B could have been is 9.475, strictly less than 9.475, so we're going to add 2 lots of 9.475. So 3.215 plus 2 lots of 9.475. Make sure you put your brackets because it's big mass. We're going to do this first. And this is 22.14165, and to four significant figures is 22.17. Now for the minimum is when you have the smallest A could have been, which is 3.205, plus 2 lots of a small number. The smallest B could have been is 9.65. So 2 lots of 9.465, sorry, 465. So 3.205 plus 2 lots of 9.465 is equal to 22.135, and this to four significant figures is 22.14. Now to finish off our answer, make it really fancy, we could leave it like this. Wrote down the max and he wrote down the min, but it is so much nicer, visually more appealing to actually write it like that. So the max A plus 2B could have been is 22.17, and the minimum is 22.14. And we're done. 9 easy marks, 3 marks each, and let's move on. Question 6, by far one of the most interesting questions. Now you can argue with me if it should be more or less than 4 marks. I think it should be less than 4 marks. It's too much for 4 marks. Okay, let's move on. Again, read the question. The area of a circle is 20 centimeters correct to the nearest square centimeters. Calculate the upper and lower bounds for the radius of the circle correct to 2 decimal places. So, they have an area of a circle which they measured correct to the nearest centimeter squared. They want us to calculate the upper and lower bounds for the radius, and when we calculated the radius, they want us to give it the answer correct to 2 decimal places. Now, just like before, one of these questions. Okay, so here what was calculated, for question 4, here what was calculated was the radius, correct to the nearest centimeter, and the radius had a rounding error, so we worked out the upper and lower bounds for it. There is nothing different with this one. What's being calculated is the area, so it has a upper and lower bound. Now, because it's been calculated to the nearest centimeter, or 1 centimeter squared, we divide this by 2 to give us 0.5 centimeter squared. So, the max of the area could have been is 20 plus that 0.5, which is 20.5. And the minimum of the area could have been is that 20 minus the 0.5, which is 19.5 square centimeters. Okay, I am going to write down an inequality. So the area was strictly less than 20.5 square centimeters and greater or equal to 19.5 square centimeters. I'm going to shrink this down. It's my working out. I don't need it for now, hopefully. Okay, let's start. They want us to calculate the upper and lower bounds for the radius. Now the area of any circle is pi times the radius squared. If we're told to work out the radius, we need to rearrange the formula. But for now, let's leave it as that. So, as you recall from question 4, big radius implies big area. And small radius implies small area. So to work out the maximum of what our radius could have been is when we had the maximum area, which was 20.5 centimeters squared, or square centimeters. And that is equal to pi times radius squared. So let's work out the radius max. Divide by pi on both sides. Divide by pi. And you got 20.5 over pi is equal to r squared. Now to get r, we need to do the inverse of squaring. So we need to square root on both sides. Square root, that looks like an r, sorry. And this would imply we are going to square root everything there. So square root 20.5 over pi. We'll square root everything on this side, and that is how we do it. And that is equal to the radius. So 20.5 divided by pi, and if we square root forgive me, calculator's a bit slow. So I'm going to delete things. So if we square root, oh come on, it would give us. So this will imply the radius is 2.5544769 point. 985 dot 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 dot. So to 2 decimal places, this radius is 2.55 centimeters. So we worked out the maximum radius could have been. Now let's work out the minimum. I'm just going to shrink this just a tiny bit. So the minimum that the radius could have been is when we have the smallest area possible. So 19.5 is equal to pi times the radius squared. So divide by pi on both sides, divide by pi, always make sure balancing. So that's 19.5 divided by pi, and that is equal to the radius squared. Now square root and square root. So the square root of 19.5 over pi, put this into your calculator, gives you R. So the square root of 19.5 divided by pi into your calculator would give a radius of 2.491393746 dot 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 dot, goes on forever. And this, the radius, we need to give our answer to 2 decimal places. To 2 decimal places, the minimum radius is 2.149 centimeters. And that's it. We worked out the minimum the radius could have been and the maximum the radius could have been. To finish off, let's put it in bounds because they want the answers in bounds. So the radius, the max, strictly less than 2.55 centimeters and greater or equal to 2.49 centimeters. Fairly easy. I'm going to put in a question similar to this, question 6. I'm going to put a question similar to that of question 5 as your homework so you could practice. I am also going to be putting question 2 as well, something very similar to question 2. Make sure you watch the video if you need more practice in doing it, and answer the questions. So 3 questions in total that must be completed by everyone.